Welcome to this video discussing command line automation of Pix4D. This is a very powerful feature of Pix4D, allowing the automatic creation and processing of projects, which has several benefits, including faster processing times, automatic running and rerunning of projects, and the ability to queue projects for processing. The Pix4D support site includes instructions on command line usage as shown. We'll get into this later. But for now, I'll demonstrate command line batching in action by comparing setup and processing via the user interface, the UI, and the same via the command line. To start, I'm going to open Pix4D, where I've set up the query sample dataset for UI processing. So this is the sample dataset that you can download off the Pix4D website, and I've set it up in a pretty standard way. So the image is already in. I'll come to the processing options, and I've chosen the 3D Maps template. Come to processing. Step 1, 2, and 3 are all ticked, so that's ready for processing. This is set up in the standard way you'd normally do it, where you would get your images in the right location, locate where the project's going to be saved, tell it where the images file is, and all the rest of it. So people are generally aware of how long that will normally take. So now I'll show how I will do that through a batch file. So I've saved my batch file in this empty folder here, in this Pix4Dmapper batching folder. So that create query batch file that you can see is basically this. First line, I'm going to record the time. Second line, I'm coming in and I'm going to give the software all the instructions that it needs to set up the project, record the time that it finishes, and then it'll just pause so you can see any on-screen messages. So I won't get into too much how-to on general command line batching. There's plenty of instructional videos out there to go through that, but I'll just go through what's relevant for this. So in this second line here, the first part is calling the Pix4Dmapper executable file and giving it different switches. So this first switch is -C, which is to run in command line mode. By doing that, the main user interface won't fire up. Then I give it a -N, which means I want it to set up a new project. I want its new project, the image directory, to be here. I want it to use the 3D Maps template, and I want it to create the project file in this location here. So I'll just close that, and I will get this over here. So the project is going to be created in the same folder as this batch file. So if I run this, you can see the command has been sent to the command line. It's thinking about it. It's giving some error messages. It seems to have some problem with I think the camera database for this one. It's not important at this point. Then it's given me the time that it's finished, and it's just asking me for a key to get out of here. So as you can see, the time on this one, it took about 6 seconds. Over here on the right, you can see that the project file has been created and the project folder. So I'll just click out of that. We'll open this project folder. And as you can see, same setup as before. The images are in. The template is set to 3D Maps. And the processing is all set. So exactly the same as it was before, except I didn't have to do anything except execute that batch file. To demonstrate how powerful this can be, I've now created a create query 2 batch file. We'll go in and we'll look at that with Notepad++. And as you can see here, I've done a copy paste on the commands that I was running before. I'm just going to punch these out into basically subversions of the same project. So I'll run that. And as you will see here on the right, it's going through each line and creating the project file and the project folder for each one. So if you've got multiple projects that you need to process, and you have a standard template that you're going to process these under, you can give all those commands to the software like this, and just create all your projects en masse in one go. Now the benefit to this is that all your project setups will be absolutely standard. They'll be completely identical to each other. There'll be no variation between anything due to user error or changing of settings as things go through. So as you can see here, again, it's given me my start and end time. And we're looking at a minute. So in 1 minute, I've set up 10 projects. So again, creating this at a rate that you just would not be able to do through the UI. Okay, so we've set our project up. So now it's time to start processing. So I've got the original project I set up back open in Pix4D. So this is the one I set up manually. So what I'm going to do now is I'm going to set this processing. I'm going to time how long that takes. Then afterwards, we're going to run it through the command line and see how long that took to compare processing times to get an idea of how much time you save by running in command line mode. When you're in command line mode, the UI doesn't have to be generated and the computer can just focus on crunching the data. So what I'll do now is note the start time, set this processing, we'll pause the video and come back when the initial processing, the point cloud and mesh generation and the DSM orthomosaic steps are all finished. And now the processing has finished. That took about 1 hour and 10 minutes all up. As you can see, all 3 steps have run. And we have our densified cloud. So for now, I will close this down and run this in batch mode to see how much quicker that runs. To run the existing project that I set up earlier through the batcher, I have to give the software a -r command. So -r is detailed here, run project. If I give it a -r, it will do the initialization run. It will also do the densification and the orthos as well. So it does the whole 3 ticks that we ran manually before. And here's the batch file. Again, the same script as before, just replacing that -n with the -r. If you were setting this up from scratch and you knew you wanted to run straight away, you could just have the first line saying the creation, and once that was finished, doing the run, so you could run them both together. Now what I'll do is I will run this batch file now. It again will give us a start and end time, and we'll be able to compare it to the 1 hour and 10 minutes that it took through the UI. So I'll set this running now, pause the video again, and we'll resume once it's finished. That run is now completed, and that came in at just a little bit over 1 hour. So in comparison to running the same data through the UI, which came in a little bit over 1 hour and 10, you're looking at around a 15% improvement in turnaround time by processing your data through the command line. Obviously, if you're processing a lot of jobs, that can add up quite quickly. So we'll go in, have a look at our run. And you can see that the project has run to completion as expected. So how can we make best use of this? Over here, I have modified that batch creation script from before, where we created these projects 1 through 10, and I've appended project initialization instructions to the end of it. So what will happen now, if you run this, these 10 projects will be created, and immediately afterwards, each project will be initialized. This is handy so the processing stops at the point where you can check your quality report and or do your ground control point marking in your photographs. If you don't want or need to do those, you could just change these -i's to -r's, and the entire process will proceed through initialization, densification, and orthomosaic generation. One potential pitfall with this can be if any of these commands fail, if there's either an error in the script or Pix4D crashes or there's any issue with your computer, the batch file will fail at that point and not proceed past it. So a good idea to do can be, instead of running everything in series like this script is showing here, to actually run the various projects in parallel. So in this case here, save the project 1 processing to one file, save the project 2 to another, and just run both at the same time. And that's what I can do here with these two batch files. I'll quickly set them running just to show them both in action, but then I'll switch them off because if those are running at the same time as I'm doing screen recording, you'll hear issues with the playback. That error just popped up because it was stopped incorrectly. So in that case, what you can do is you can run all those batch scripts in parallel, so if any one of them fails, it won't knock the other ones out. You can also be more granular in your instructions in the batch file to tell each individual script what computer resources they can use at the time. These instructions are detailed at the bottom of the command line instruction page, where you can specify CPU threads and also enable disable the GPU, the CUDA aspect of it. You can provide that information, or you can just leave it and let the computer figure out which script gets which resources. And that pretty much finishes it up for this video. In my next video, I'm going to go through options to actually automate the generation of batch files. Obviously, looking at this, there's a lot of scope for error in these script files. If you introduce a wrong command, a wrong folder location, or anything like that, it will cause your scripts to fail, and you won't always get very descriptive information to tell you what was wrong. So it can be a good idea sometimes to automate the actual production of the script. There are different ways to do it. If you have some programming ability, you can do it that way, but there's also a way to produce this stuff that doesn't require you to have any particular programming knowledge. So I'll go through that in the next video.